Hello everybody, welcome to the shop. I want to talk to you a little bit about some welding tips and tricks that I've picked up over the couple of years I've been welding, totally self-taught. By the way, if you are interested in welding, check out WeldingTipsAndTricks.com. He has both a website and a YouTube channel under the same name. He does mostly TIG stuff, but anyway, very good teacher. Great YouTube channel. But anyway, I'm doing some welding on these two backhoe mount pieces, and I wanted to talk a little bit about welding heat. And I've picked up from people that I've talked to about welding, other home shop guys, that they seem to have the thought that hotter is better, and if you want it to be sort of strong, you just weld it normally, and if you want it to be really strong, you just crank up the amperage or the voltage or whatever, depending on what type of welder you have, and just really melt that stuff together. But that is really not the case at all. To a certain point, yes. I mean, you want to have a good strong arc, a good puddle, a good penetration, but if you go too hot, you're just going to start burning stuff up, and you really need to go to the next size electrode. Or if you're doing MIG, I don't really know too much about MIG, but you need to go to a larger wire size and or increase your wire speed. But anyway, I welded these two pieces, these two 90-degree joints here, at two different heats. This one I welded at 109 amps, and this one I welded at, I believe, 95 amps with my 1938 Westinghouse arc welder. I'm just going to show it to you guys. You might be interested. There it is. See, the reason for the odd amperages is because you just have a range, 1 through 9 in a range, so you just choose. Yeah, so I started at 109, then I went to 95. Anyway, I want to show you the difference between those two amperages. And also, I'm welding with 1/8 inch 6011, made by Lincoln. I like the Lincoln rod, it's pretty good stuff. And also 6011 is my favorite rod. I'll get onto that in a minute. Anyway, let's start with the 95 amp, which is right here. And the first thing I have laying here is a spent piece of rod, welding rod, that I welded this piece with at 95 amps. And look at that. See, the flux is, normal color, is just burnt at the end like normal. And that's that. Nothing too special. Now there are a couple little hiccups here where I did tack weld this, and then when I welded over the tack weld continuously, it kind of got a little bit ugly. I might re-weld it, or I don't know. Just bear with me. So I'm just going to run along the weld bead here. I'll just let you guys check it out. Now this spot right here is really the, in my book anyway, the textbook example of a nice arc weld. That it has that nice stack of dimes appearance. Each dime is stacked an even distance apart, and there's a little hiccup there, and then another nice section, all nice stack of dimes. And you'll see that nothing's too globby. It's not bulged out. The weld bead is a little concave. The weld bead is just the right size. There's no undercutting on the top piece, where if it's too hot it'll melt and just blob down. But it's not undercut or anything. It just looks like a nice weld. And then let's move over to the 109 amp. Now here is a spent rod. Of course, some of the flux is broken off there as I stepped on it, but here is a spent rod from 109 amps. Look at that, it's incinerated. Even though I only welded up to that tip, obviously, it's just incinerated. Now again, there is a couple spots where I welded over tack welds and it made it kind of globby. Like this spot right here, see it kind of built up. It's very convex because I welded over a spot weld. But you see it's a little more uneven. and there isn't really any one good section of weld. It's not horrible, definitely not horrible. It'll hold together just fine, but it's really just not as nice. And it might be a little hard to see on the camera, but each dime in the stack of dimes is a little thicker and spaced out a little farther. And that's because, since I was welding with more heat, the rod was depositing a lot faster, so I had to move a lot faster to keep up with it, otherwise it would just glob up. So I was rushed. With 95 amps, the rod just burned off at a nice slow pace, and I was able to do the whip and pause just like you're supposed to. You let it bead up a little bit, then you whip forward and you go back, and you just weld in a really nice bead. You can keep a nice pace, you're not rushing, and it just runs really smoothly. Also, with the 109 amp weld over here, when I was welding, I could see it was really digging in. It was very loud. It was spattery. Well, 6011 is spattery anyway, but it was just really aggressive, and it's hard to describe. I can't do arc shots. I haven't figured out how to do a good arc shot with this camera, so you'll just have to bear with my description. But it was just very aggressive, and the 95 amp welded a lot smoother. So, will both of these welds hold? Absolutely, they will hold perfectly fine. I would choose the 95 amp over the 109 any day of the week, but they're both perfectly serviceable. However, I don't feel that the higher heat weld is any better than the lower heat one. The lower heat one is much more consistent, it's better in appearance, and it'll work just fine. Also, the fact that you're just incinerating your rod as you're welding is an indication that you're going too hot. And as Jody from Welding Tips and Tricks says in a couple of his stick welding videos, and I've taken this suggestion to heart, and I'll tell you guys as well, you should weld with a stick rod at the lowest amperage where you don't stick the rod. So basically, if you're starting out with a new rod or a new whatever that you're not familiar with, or maybe a welder where you're not familiar with the settings, start with a low setting and then keep increasing the amperage until you get to a setting where you're not constantly just trying to start an arc and getting it stuck and breaking the stick off and trying to start an arc again and getting it stuck. Once that happens, once you can strike an arc and just hold a nice arc, that's the temperature you want. And that's what I've done with this Lincoln rod. When I first got it, I did some welding with it, and I found that 95 amps was just right. I can go a little bit lower in the amperage if I need to, but it doesn't weld quite as well. If I was welding some thinner material, I might go for a slightly, maybe 85 amps. I would do that. But 95 is just right. And if you need to weld thinner material, you should use a smaller welding rod, of course. But if you don't have it, if you're out in the field or whatever, you got to use what you got so you can lower the amperage a little bit and make it work. So that's one of my tips about heat. The next one is just a little. I tell this to everybody when I'm talking about stick welding. I think 6011 is by far the best rod to use. If I had to use just one rod for the rest of my life, I would choose 6011. It has a very light coating of flux, so when you weld, of course I wire wheeled this, but there wasn't a big fat coating of flux over this, or slag I guess. It cleans off very easily. It digs very well. When you're welding, you can see it just cut a hole into the material you're welding and then fill it back in with molten filler metal. So you know you're getting good penetration. It's a very aggressive rod, which doesn't make it good for thin material, but for something like this is a 3/8 thick material. It's perfect. It's best at burning through paint and rust and slag and mill scale like this. And it's an easy starting rod. It's an easy restarting rod. I just plain like it. 6013 is the really popular farmer's rod, they call it. It's similar to 6011. It shares the 60 number, which is the tensile strength, 60,000 psi. But it has a thicker coating of slag. It runs beautifully. It's a smooth bead, smooth arc. This has a lot of spatter, 6011. I wire wheeled a lot of the spatter off, but there's little BBs all over the place when you're done. 6013 has a little less spatter. But, yeah, you know, like I said, nice smooth bead, runs real nice, thick coating of slag that sometimes gets in the way, because if you're welding, sometimes if you're welding over a gap, that slag will fill in the gap before the weld metal does, the filler metal. And you think you've welded the piece together, but when you chip the slag away, you chip the slag away between the two pieces and it falls apart because the slag was actually holding it together, not the filler metal. And I've also used 7018, and 7018, I don't know, I think 7018 is better served for DC welders. I think it was specifically made for that, and I've used some 7018 AC, and it's just, I don't quite like it. There's so much flux. It's a giant thick rod, tons of flux on it, and the flux just, when you're welding, just runs off like lava. It gets in your way, it smothers the arc. You have to turn the heat way up on the welder to get enough arc force to blast the slag out of the way. So maybe a DC welder would be better. I know lots of people swear by 7018, but anyway, that's my little spiel on welding rod. And the last little trick that helps me out when you're welding, especially when you're welding and ending on an edge like this, you might notice you get to the end and then you try to fill it in here so it's not a divot, and then you'll just burn right through and you'll just chunk out the corner. And I struggled with that for a while until, again, Welding Tips and Tricks, he helped me out. You weld as normal, then once you get to the end of your weld bead, you backtrack maybe 1 or 2 rod diameters and hold it there for a second, and then you pull the arc away. And that allows, firstly it pulls the heat away from the corner, and it allows the weld to puddle a little bit before you pull the rod away. Because if you're welding, you just pull the rod away, you get a little crater and sometimes like a little blowhole looking thing. But if you weld and then backtrack just a hair, hold it for a second and pull out, that stops. One last trick. I mentioned the whip and pause earlier, and that's the best, in my opinion, the best technique to use for 6011, because 6011 is a fast freeze rod. Oh, that's another reason I like 6011, is because you can weld overhead or vertical, and the weld freezes, the molten metal freezes really fast, so it doesn't have a time to sag or drip off or get all gloobery. Yes, gloobery is a word. Anyway, what whip and pause is, so I have to switch to my my right hand here, hold my camera with my left. Anyway, with some rods you can just drag the rod like 7018. Some people like to do a little C shape or something, or something or other, write their name out in cursive as they're welding. But the best thing to do with 6011 is you strike your arc and you get your weld bead going. You whip it forward about 1 electrode diameter, and then go back a little bit and hold it. Then pull it forward a little more, then back, and then forward, back. Just, that's why they call it whip and pause. Whip it and pause. And that's what gets these distinct ripples. That's also what allows this rod to freeze, because when you whip away from your main puddle, it freezes. And then so here's your main puddle, you whip away, it freezes, and then you come back to here and make that puddle. Then you whip away, that freezes, and you come back to there. Whip away from that puddle, it freezes, come back to there. That's how you can weld overhead and vertical and everything with this rod and not have it rain lava on you. Well, everybody, I think that about sums it up. I hope that helps out some of you guys. I'm sorry I can't do any arc shots or in action shots, because I haven't really figured out how to get a good action shot on this camera. But if you do want to see some cool arc shots, again, check out Jody at WeldingTipsAndTricks.com. I'm not affiliated. I just like him. He's a great YouTuber, great teacher. Anyway, that's it for now. Thanks for watching. Hope this helps out some of you guys in your shop welding stuff together. I'm gonna get back to my backhoe project here. So thanks for watching. Make sure to leave me a thumbs up if you like this. Leave a comment, hit the subscribe button if you haven't already and you want to see more of this stuff in the future. And as always, come back for more.